Put your hands together.
Wow, what an audience. Thank you all for coming. I'm super excited to be here. Rachel, thank you so much for the introduction. We don't have that much time. It looks like we've got only like 20-ish minutes. So how about we start by talking a little bit about what Linea is for those of you in the audience who aren't fully aware of what Linea is and how it connects to this L2 ecosystem. And by the way, my name is Sam Kessler. I'm an editor at CoinDesk. And yeah, I'll be moderating today. Excited to be here.
So, hello everybody. I'm Nicolas Liochon, and Linea is a ZK EVM. So, what is a ZK EVM? It's a layer 2 that works at the bytecode level, exactly like Ethereum mainnet, and that does prove the correctness of the execution. And the problem that it solves is it makes transactions much cheaper, basically 40 times cheaper than mainnet today, and it's going to decrease again. And it makes this price as well more stable with much less fluctuations due to activity because it scales.
So there's a difference, of course, between ZK EVMs and optimistic rollups. Can you talk a little bit about, the landscape, like where you fit in, with, I think, there's something like 20 or 30 different L2s that have come up over the past year or so. Let's talk a little bit about that.
Yeah, so at the very beginning, what we had was ZK rollups. It's basically back to 2018. The idea was, in order to scale Ethereum, we need to do the calculation off-chain and to prove on-chain that it's correct. But back then, it was a very advanced cryptography. We didn't really know what was possible and what will be the impact on performances, the complexity of the proof, and so on. So what was done at the beginning was what was called specialized rollups, just for payments. And the idea that we could execute the bytecode instructions of an Ethereum virtual machine that was defined much before without any knowledge of what was the proof system at that stage was nearly seen as impossible. So for this reason, many people tried different branches. So you had some ZK rollups that were specialized. Then some people said, yeah, actually the zero-knowledge technology is too complicated. We're going to play a different game. We're going to have fraud proof. That was the optimistic rollups. So you've got one branch ZK rollup specialized, another branch optimistic rollups. Then people said, okay, we're going to try to have generic execution, but not with the EVM, it's too complicated, so we will have a specialized virtual machine, and that will be yet another branch. And then people said, yeah, but actually there are different ways of doing virtual machines, so let's try other branches and other branches. And 2 years ago, it became clear that actually doing the EVM with proof was actually possible. That's created, in a way, the last branch, which was ZK, the proof, plus the EVM Ethereum virtual machine. And that's a technical decomposition, but there's actually another one which is, I would say, business and functional. People said, okay, some people are building technical layers, optimistic, ZK, specialized, and so on, all those layers. But actually, we need to build an ecosystem. So people said, okay, I'm going to reuse one of the technical layers, optimistic, to build one ecosystem, specialized sometimes for gaming, for DeFi, and so on. And so you have multiple technical layers, multiple ecosystems, and you do a big matrix of all this, and you have what we have today.
So there's a few different things that I want to cover today. Obviously I want to talk a little bit about Linea. I also want to talk about L2s generally, the state of Ethereum. So first off, zooming out a little bit, Ethereum is about to undergo a really big update called proto-dank sharding, which is this thing that is supposed to help make transactions even cheaper for rollups like your own. And maybe you can talk to me a little bit about what that upgrade is and what impact you expect it to have on services like your own.
Yeah. So the idea of a rollup and a ZK rollup is it as secure as Ethereum. And what we mean by this is if a rollup disappears completely, you can still recreate it just from what you have on Ethereum. It means that everything that is happening on the layer 2, on the rollup, is first proven, but as well, the data is written on Ethereum, so anyone can recreate the full state. So when you do this, and you do this with a lot of transactions, the issue that you have is you need to write an incredible amount of data. So we add some optimizations around compressing the data, around removing the useless data. There's many things that you can do, but at the end of the day, you're writing a lot of data on Ethereum layer 1. So in the past, we were kind of using the generic layer 1 system, like the EVM allows you to write data, so you write data. That's fine. But the idea of the Ethereum Foundation was, let's have something specialized just for data that will be used basically mostly for rollups. And the nice thing about this is, because it's specialized, it's obviously much less expensive. But the second point that is quite important on the long term is something that can scale easily. So when they're going to start in a few weeks, they will start with a reasonable amount of capacity, but it's something that can change, basically multiply by 10, 20, 50 without any major difficulty. It's basically changing a setting. So thanks to this, we've got the capacity to multiply immediately the capacity of a rollup by something like 5, and then by 250 without having to spend too much brand power. So that's what this EIP is providing.
So I was at a dinner the other night, and a lot of folks were talking about L2s, the proliferation of so many of them, and what it actually says about Ethereum as a protocol, and both the successes it's had in cultivating this ecosystem on top of itself, but also maybe the failures that it's had as an ecosystem, the fact that it needs so many chains built on top of it in order to fulfill its ultimate goal. And I wonder, what your response is to this idea that Ethereum, in order to achieve its ultimate ends, has kind of relied on a lot of ecosystems like your own that, and we'll talk about this, have varying, we're going to talk about security a little bit, but we're still in the process of building these things. So a lot of the traffic that, is now going onto Ethereum is going through a lot of these services that don't have the core kind of, use case, I guess, value add that Ethereum seems to promote itself as having.
Yeah, so it's interesting because I think that the view is changing with time, and we don't know yet what we will have at the end. So when we started, the need was we need to scale, and we don't know how to scale the EVM. So let's try different things. And now we're at a point, and the idea that is behind this is, okay, as anyway we can't do the EVM, we can go into crazy experimentations. Let's try a totally different virtual machine. Let's try specialized opcodes. Let's try everything. What appears now is that actually the EVM, we know how to scale the EVM, and a side effect of this is it puts back Ethereum in the loop, because what Linea is doing, it's executing EVM instructions exactly like the mainnet. So it means that Linea implements the EVM specification defined by the Ethereum Foundation. So Ethereum is back in the center of the world. Ethereum Foundation basically decides a part of the future of Linea because we're implementing this specification. And there are other people implementing this specification as well, which means as well basically more power for the Ethereum Foundation, because it's not a single team that decides everything and that can say, no, I don't want to do it. There are multiple teams doing it. They're all kind of competing in a very positive way to have the best possible implementation, the more aligned and the fastest, which leads us back to the situation when we have for the Ethereum layer 1 client, when you have one specification by the Ethereum Foundation and 4 clients, 5 clients. Yeah. It's back to the story. And it's the next step, very likely, that we expect at Linea is actually rollups will be secured by multiple different provers, because as there are different implementations, you can use multiple of them to increase the security of the system. And once it will be kind of validated enough, reliable enough, seen as reliable enough, it's very likely that it will move back to the layer 1, and the layer 1 will be using this technology. It's a future in maybe 5 to 10 years, I don't know, depending on how fast we are working. but it's a very likely future.
So what trust assumptions are there built into Linea right now? We're going to talk a little bit about security and the stuff that you're, in the process of building, but there's 355 or something, if I checked right before this, $1 million, in this system. Who are those depositors trusting with their funds? What pieces of your system?
Yeah, so fundamentally, you trust that Ethereum layer 1 works. Like if Ethereum layer 1 disappears, everything is lost. It's
Sure.
as simple as this.
But in terms of consensus,
So
like as a company.
that's the first layer. The second layer is you trust a little bit that the proof system works. And the proof system is quite complicated because when you say that you trust the proof system, you need to trust the mathematical definition of it. That's one thing. You need to trust part of the implementation that is going to verify the proof, not everything but the part that verifies the proof. But you need as well to trust that we did a good job in what is called the arithmetization of the execution, which is 600 pages of specification, so something quite big. So, and I say you need to trust this a little because given the complexity, we know that it's not going to be perfect day one.
Yeah.
So we have another layer of security, which is the number of people that can send a proof is limited. So we call this having multiple layers of security, making the system a single failure won't make you lose funds. That's how it works. So that's called training wheels. That's how we globally call that. And that's a generic mechanism. And there's a last trust assumption is as the system is evolving, we can upgrade the system. So here you have a security council validating that the upgrade is actually valid. So you have this trust in the security council, which is at the end of the day basically Consensys. That Consensys is not going to be a very bad upgrade without any warning. So there are some delays and so on, some precautions, but that's a basic assumption.
So there's a tool out there that some of you in the audience might have used, L2s, which is where you can get a lot of this information on your own ecosystem and others. And I'm curious, so you're currently like a stage 0, as are most of your competitors.
Yeah.
Basically all of your direct competitors are quote unquote stage 0 rollups, which refers to the kinds of training wheels that we're talking about that you still have. I wonder if you can, like, even sitting here in 2024, think about or help us understand when will you be a stage 1 or stage 2? These aren't perfect or scientific measures exactly, but when will you kind of start taking these training wheels off to make it to those latter stages?
Yeah, so actually what we're working on right now is adding training wheels to add more security to the system. So a lot of the things that we're doing is let's have other type of verification, other type of checks in order to make the system more secure. The training wheel, the biggest training wheel, and that's the biggest pain point for everybody is really the fact that we can upgrade the smart contract. Given the changes in the technology, it will take a while before we remove this. Let's be very clear. So we're really on an idea that we're going to add layers of security for at least 3 years. And every new layer of security that I can add, I will add it. And then we will start to say, okay, it's stabilized. We can remove those layers. But to me, the ultimate end game is really what I was explaining about having multiple provers, because we know that the technology is complicated. We know that it changes. So if we can have a system when a single rollup is secured not by a single proof but by multiple proofs, we have here a perfect solution. And that's the end game. And the end game requires to have multiple zkVM implementing the specification perfectly, which is going to take 2 years. And then we need to have this type of gentleman agreement that we're sharing the implementation. It will take much less than a year, and we will be ready to play.
So we've talked about this before in a previous panel. I think it was last year, but in terms of how you communicate these constraints and these security limitations, these training wheels to users, how do you, as someone who's building this technology, think about how users should be considering the safety of their investments relative to locking them up on Ethereum directly? what would you tell a family member or a friend about your system or others in this orbit? Should I put all of my ETH, into Linea? Like, is it a safe, way to secure my funds?
Yeah, so the security is very global. So it's not only like should you put all your money on Ethereum itself? And how are you going to manage this? And I think it's really a key topic globally for the ecosystem because what we're saying with rollups, it's basically in the past we are saying, okay, Ethereum cannot be used anymore because there are so many usage already that the transactions are too expensive. We can't put more use case there. We're at the maximum. And we're removing this limitation. Now the transactions are much cheaper, so you can speak to much more people. And again, it's going to scale, so you can have more use cases. And the point is now we've got this, it means that we've got new users. And there's new users, they may not understand how Ethereum works, they may not understand how wallet works. There's a lot of complexity that they don't know. And we think that on top of Rollup itself, there's a global security approach to have, because the data that we have from MetaMask is when someone enters the ecosystem and loses his funds in less than 6 months, basically, he won't come back. Said, okay, it's too complicated, I'm leaving forever. So we really need to be sure that it does not happen, basically. So people who are new to the system can do things that are not, that will not put them at risk. And I think it's really a major responsibility for us to do this if we want to build a long-term ecosystem. So that's how we do that.
So we are increasingly, I think, seeing this trend on Ethereum that we've, it really started, I think, on Cosmos, this idea of app chains. So blockchains that pop up built on top of some base chain or that can draw security from some other, system that are specific for one particular use case. Whereas Linea and, the Scroll, Polygon, and a lot of these optimistic rollups, they're general purpose, the ones that we're talking about when we're talking about like 32 L2 chains or something. How do you see your model, this general purpose model, fitting in a world where it's easier and faster to design ZK circuits that are more specified to particular use cases?
So that's linked. I mean, it's interesting to look at successful applications. And a successful application that we have today is, for example, Farcaster. And there's a debate, AppChain, layer 3, layer 4, layer 5. Is Farcaster a layer 3? I don't know. But it's a successful application. And why? Because basically they've been able to say, okay, some parts are very important and needs to be secured by the account. So it goes onto the layer 2. And there are some parts that are very complicated to do in a decentralized way. It's still a decentralized problem. You need to distribute all the images, all the cast, all the data everywhere in a secure way. Maybe you need to be able to prove that you're actually distributing it and you're not lying and providing some data to some people and some other data to some others. And you need to do that. And I think it's very interesting to look at it from what do you need to do? Do you say, oh, I've got a rollup, so everything is a rollup? Well, no, that's not the right way to do things. The right way is to say, okay, I've got a problem where I need the blockchain to secure this part, and then I've got other problems that can be quite complicated in terms of cryptography and distributed systems, and they need to be sorted out. So the way we see things is we should have a single level of security, which is the maximum. The story that you can play with options all over the time, saying, yeah, I don't need this security, it's just too complicated, it's confusing, and you're just going to get it wrong. To me, just an excuse to put the responsibility on the user, saying, oh, yes, you were told that it was not really secured, it's your fault. No, it should be secured properly without playing games. And then you need specific tools to build the other parts of your application, and you should not try to force a rollup when it's not a rollup. So what we have in Linea, in many cases, what you want to do, you want to have some advanced cryptography, and for example, to calculate options, some results, and to put them on-chain. And we have a library to do this that is actually totally independent from Linea, but is actually used by, I would say, nearly many blockchains, layer 2s all over the place. This library is called NARC, and people can use it to build advanced features independently of a rollup, but they will basically at the end push the result of this calculation envelope. And it's a key different in approach, I would say, on linear, that we say something that seems a little bit obvious in my opinion, but applications should really look at their needs and not try to use a blockchain for everything, but just use the blockchain for what they need.
Awesome. I think we're at time, but thank you so much, everybody, for joining. Thank you for giving me the opportunity to talk about Linea and L2s and Ethereum, and yeah, enjoy the rest of the conference.
Thank you very much. Thank you very much.